After starting this module, you shall be able to know what is the time value of money. This module will also help you learn how to calculate the present and future value of money and what is the difference between nominal and effective rate of interest. This module will further help you in understanding some practical applications of time value of money in financial management decisions.
Financial planning practices work with time value problems in terms of how the value of money changes with time. Time value problems become an issue within a range of different planning scenarios involving profit earning, loan rates and budgeting practices. Three techniques for solving time value problems involve determining the present, future and recurring values of money over one or more time periods. Time value of money is an important concept in financial management. It can be used to compare investment alternatives and to solve problems involving loans, mortgages, leases, savings and annuities. Time value of money is based on the concept that a rupee that you have today is worth more than the promise or expectations that you will receive a rupee in the future. Money that we hold today is worth more because you can invest it and earn interest. After all, you should receive some compensation for foregoing spending. For instance, we can invest our rupee for 1 year at 6% annual interest rate and accumulate rupees 1.06 at the end of the year. You can say that the future value of the rupee is rupees 1.06 given a 6% interest rate and a 1 year period. It follows that the present value of rupees 1.06 we expect to receive in 1 year is only rupees 1. A key concept of time value of money is that a single sum of money or a series of equal, evenly spaced payments or receipts promised in the future can be converted to an equivalent value today. Conversely, you can determine the value to which a single sum or a series of future payments will grow to at some future date. Over time, money investments increase in value as a result of interest earnings accumulated within the lending or loan industry. Interest amounts paid represent the cost of borrowing money for a specified period of time. In effect, interest earnings or interest paid determines the time value of a particular investment or debt. As different financial transactions involve varying interest rates and time periods, problems concerning the time value of money attempt to incorporate the effects of time when determining potential profit earnings or debt costs.
The concept of time value of money holds considerable importance while taking financial decisions. It refers to the fact that money received today carries more value than the same amount of money received at some other date in future. This is based on the principle that a rational individual always holds a preference for possession of a given sum of money today rather than possessing the same sum of money tomorrow. Such time preference for money arises because a number of reasons. Risk associated with future. The future is uncertain, and because of the risk involved due to this uncertainty, an individual prefers to have current money rather than receiving the same in future. Preference for present consumption. Every individual has a preference for present consumption as compared to future consumption. because the present money can be used to make purchases of some consumer durable or other requirements, and also the purchasing power of money decreases with time due to inflationary conditions prevalent in the economy. Reinvestment opportunities. Even when an individual does not need money for consumption purposes, he always has an opportunity to reinvest and earn some return S on it. For instance, if an individual has been given a choice to receive rupees 100 either today or after 1 year, and the rate of interest offered by bank on deposits is 8% per annum, he would definitely prefer to get rupees 100 today because he can deposit the same in the bank and earn rupees 8 on it. So, at the end of the year, he would have rupees 108.
The concept of time value of money holds considerable importance while taking financial decisions. It refers to the fact that money received today carries more value than the same amount of money received at some other date in future. This is based on the English proverb, "A bird in hand is better than the two in the bush," which means that a rational individual always holds a preference for possession of a given sum of money today rather than possessing the same sum of money tomorrow. Such time preference for money arises because of a number of reasons. The first reason is risk associated with future. Future is uncertain, and because of the risk involved, due to this uncertainty, an individual prefers to have current money rather than receiving the same in future. For instance, he may have an apprehension that probably the person from whom the payment is to be received becomes insolvent or runs away or dies. Preference for present consumption. Every individual has a preference for present consumption as compared to future consumption, which is uncertain, because the present money can be used to make purchases of some consumer durable or other requirements, and also the purchasing power of money decreases with time due to inflationary conditions prevalent in the economy. Reinvestment opportunities. Even when an individual does not need money for consumption purposes, he always has an opportunity to reinvest and earn some return on it. Because of all above stated reasons, individuals have time preference for money. It is very important for the finance manager to take into account time preference for money, otherwise he will make incorrect decisions. In most of the financial decisions, there is a series of cash inflows and outflows occurring at different points of time. So, in order to make them comparable, time value of money helps in converting the monies received at different points of time into equivalent values at a particular point of time. Money has time value. A rupee today is more valuable than a year hence. It is on this concept the time value of money is based. The recognition of the time value of money and risk is extremely vital in financial decision making. Because of all aforementioned reasons, individuals have time preference for money. It is very important for the finance manager to take into account time preference for money, otherwise he will make incorrect decisions. In most of the financial decisions, there is a series of cash inflows and outflows occurring at different points of time. So, in order to make them comparable, time value of money helps in converting the monies received at different points of time into equivalent values at a particular point of time. Present value problems attempt to determine the present or current value of future cash amounts based on time periods and applied interest rates. By working backwards, the present value technique calculates the current value of a future cash earnings amount based on a certain time period and interest rate. In effect, the present value technique discounts a future cash amount to arrive at a present value amount. Once calculated, the present value amount equals the amount of money needed to generate the future cash amount. Annuity and bond investments involve recurring interest earnings over set periods of time. Some investment products generate annual interest earnings, while others may produce quarterly or biannual earnings. The earnings rate produces a cash flow stream that is generated by time value effects or interest rates. Problems involving cash amounts for recurring interest earnings can use present and future value techniques. Since cash flow streams involve multiple amounts, be it 4 times a year, annually or biannually, present or future value techniques add these amounts together when computing a present or future value. For example, the future value of a rupees 100 annuity investment over 10 years at 10% equals the sum total of each amount earned per year or rupees 200. Present value techniques use the same process in terms of figuring present values for each year's earnings, which represent future cash amounts. Any value that occurs at the beginning of the problem or the beginning of a part of the problem is a present value. The key is that the present value occurs before any other cash flows. Usually, when a present value is given, it will be surrounded by words indicating that an investment happens today. The future value is usually the last cash flow. Obviously, it is a cash flow that occurs at some time period in the future. The future value is a single cash flow. If it occurs more than once, then it is probably an annuity payment. An annuity payment is a series of 2 or more equal payments that occur at regular time periods. Each payment, if taken alone, is a future value, but the key point is that the annuity payment is a recurring payment. That is, there are more than one of them in a row.
In most of the financial decisions, there is a series of cash inflows and outflows occurring at different points of time. So, in order to make them comparable, TVM helps in converting the monies received at different points of time into equivalent values at a particular point of time. There are two techniques of TVM. First is the technique of compounding, which helps in finding out the future value of present money. It can be examined under two heads. Future value of a single sum of money. The future value of a sum of money is given by the formula shown, where future value is represented as FV, PV is equal present value, R is the rate of interest, N is the number of years for which compounding is done. For example, Mr. X deposits rupees 5,000 today in a bank at 12% rate of interest compounded annually for 2 years. By using the formula for future value, we find out the future value of the deposit is equal to rupees 6,272. The future value of present money can also be found out by multiplying the present value by a compound value factor that can be obtained from compound value of a given amount table. From CVF table, one can obtain compound value factor for several combinations of R and N. So, in the above example, future value can be calculated as shown here. Non-annual compounding. If the time period N is not annual, then the formula for calculating the future value will be modified as shown, where M equals number of times of compounding per year. Let us now find out if the future value will change if compounding is not done annually with the help of the previous example. By putting in the values, we get future value equal to rupees 6,335. We can observe that future value is higher when compounding is done quarterly rather than annually. Thus, more frequently the compounding is made, higher is the future value. Second head under which compounding can be explained is future value of a series of equal cash flows or annuity. It is a series of equal cash flows occurring every year for a number of years continuously and is also called an annuity. For example, suppose Mr. X opens a recurring account in a bank where he deposits rupees 1000 every year for 10 years at 10% per annum. The future value of his annuity can be found out by multiplying the annuity amount by compound value annuity factor that can be obtained from compound value annuity factor or CVAF table. Let us now discuss if there is any difference between the nominal interest rate and the real interest rate. There is no difference between nominal and effective rate of interest if the compounding is done annually. However, if there is m times compounding every year, the effective rate can be calculated as shown, where RE equals effective rate of interest and R equals nominal rate of interest. It should be noted that the effective rate is higher than the nominal rate if compounding is done more than once in a year. The second technique is the discounting technique. It helps in finding out the present value of future money. It is the reverse of compounding technique which helps in finding out the future value of present money. It can also be explained under the two heads. The first one is through present value of a single sum of money, and the formula for the same is shown here. Where PV equals present value, FV equals future value, R equals rate of interest, and N is equal to the number of years for which discounting is done. Example, suppose Mr. A is to receive rupees 50,000 at the end of 5 years from now. If the required rate of return is 10%, the present value can be found out using the formula as 31,046 rupees. The present value of a future sum can also be found out by multiplying the future value by a present value factor that can be obtained from present value of a given amount table or PVF table. From the PVF table, one can obtain present value factor for several combinations of R and N. So, the same example can be solved using the PVF table as shown here. That is, PV equals rupees 31,050. The second head is the present value of a series of equal future cash flows or an annuity. The present value of an annuity can be found out by multiplying the annuity amount by present value annuity factor that can be obtained from present value annuity factor or PVAF table. The formula for the same is where PV equals present value, A equals annuity, PVAF is equal to present value annuity factor table, R equals rate of interest, N equals the number of years for which compounding is done. Example, suppose Mr. A has to pay 5 installments of rupees 4,000 each at the end of each year for the next 5 years. How much should Mr. A pay today as a lump sum amount if he does not want to start an installment plan, if the required rate of return is 10%? This can be found out as rupees 15,164. Now, we shall discuss the concept of perpetuity. Perpetuity consists of an infinite series of equal cash flows occurring at regular intervals for an indefinite period of time. The present value of such perpetuity can be calculated as follows, where A equals amount invested per period. This can be further simplified to present value equals A upon R. Example, suppose Mr. A invests rupees 2,000 every year indefinitely in a recurring bank account, which earns him 5% per annum. The present value of such perpetuity is given by PV equals rupees 2000 by 0.05. Therefore, PV equals rupees 40,000. Let us now discuss the concept of annuity due. It is different from ordinary annuity in the sense that under annuity due, the cash flows occur at the beginning of each period instead of occurring at the end of each period. The calculation of future and present value of annuity due is different and can be explained as follows. Future value of annuity due, where A equals annuity amount. Example, suppose Mr. A deposits rupees 4,000 in the beginning of every year for 10 years at the rate of 8% per annum. How much will he get after the expiry of 10 years? This can be found out using the above concept and the formula such that future value equals rupees 62,584. Present value of annuity due. The formula for present value of annuity due is, in the above example, the present value of such deposits can be found out by substituting the values in the above formula. Therefore, we can say annuity due equals normal annuity multiplied by 1 plus R. The concept of TVM has got a lot of practical importance. It is often used by finance manager for a variety of financial management decisions such as capital budgeting decisions, valuation of securities, and so on. Now, we shall discuss three very important practical applications of time value of money. These are 1. Sinking fund, 2. Capital recovery, 3. Deferred payments. Sinking fund. Often, a finance manager is faced with a decision to accumulate a certain specified sum of money after the expiry of a fixed period of time in order to replace an asset or to repay a liability such as redemption of debentures. In such a case, a fixed amount of money is kept every year for a fixed period, which will be invested for the remaining period at a certain rate so that the total accumulation at the end of fixed period becomes equal to the target sum. It is similar to an annuity. Where A equals annuity amount. Example, suppose a company has to replace an existing machine by a new modernized machine worth rupees 10 lakhs at the end of 5 years from now. The amount that the company should accumulate every year at 10% rate of interest so that it becomes rupees 10 lakhs after 5 years comes out to be rupees 1,63,800. Capital recovery. Sometimes a firm needs to find out the equal annual installments in order to repay a specified amount of loan together with interest taken today. Therefore, the formula for calculating the equal annual installments at a given rate of interest can be seen as where A equals annuity amount. Example, suppose a company borrows rupees 5 lakh today to be repaid in 5 equal annual installments at the end of each year. The interest charged on such loan is 12% per annum. We can find out the size of each installment using the concept of capital recovery by substituting values given in the formula. We can get the value of each installment equal to rupees 1,38,696. Deferred payments. Sometimes the payment of installments to repay the loan does not start immediately but after a gap of certain years. This is known as deferred payments. In this case, although the repayment starts after some years, but the borrower needs to pay the interest for that period also when no installments are made for the payment of loan. That is, the time gap between the date of loan to the date of first payment. This would become more clear by taking an example. Suppose Mr. X took a loan of rupees 5 lakh to be repaid in 5 equal annual installments beginning 3 years from now. The rate of interest charged by the bank is 10% per annum. Let us now find out the amount of annual installment. We can find the value in 2 steps. In the first step, we calculate the future value of annuity of 5 years using the formula future value equals loan amount into CVF for R% and N time period. This comes out to be rupees 6,05,000. In step 2, we calculate the amount to be paid every year for 5 years beginning 3 years from now in order to repay his loan taken today. This comes out to be rupees 1,59,589.
Most financial decisions, such as the purchase of assets or procurement of funds, affect the firm's cash flows in different time periods. For example, if a fixed asset is purchased, it will require an immediate cash outlay and will generate cash flows during many future periods. Similarly, if the firm borrows funds from a bank or from any other source, it receives cash and commits an obligation to pay interest and repay principal in future periods. The firm may also raise funds by issuing equity shares. The firm's cash balance will increase at the time shares are issued, but as the firm pays dividends in future, the outflow of cash will occur. Sound decision making requires that the cash flows which a firm is expected to give up over period should be logically comparable. In fact, the absolute cash flows which differ in timing and risk are not directly comparable. Cash flows become logically comparable when they are appropriately adjusted for their differences in timing and risk. The recognition of the time value of money and the risk is extremely vital in financial decision making. If the timing and risk of cash flows is not considered, the firm may make decisions which may allow it to miss its objective of maximizing the owner's welfare. The welfare of owners would be maximized when net present value is created from making a financial decision. It is thus time value concept which is important for financial decisions. Thus, we conclude that time value of money is central to the concept of finance. It recognizes that the value of money is different at different points of time. Since money can be put to productive use, its value is different depending upon when it is received or paid. In simpler terms, the value of a certain amount of money today is more valuable than its value tomorrow. Thus, we can say that it is not because of the uncertainty involved with time, but purely on account of timing. The difference in the value of money today and tomorrow is referred as time value of money.
Now, we will summarize what we have learned in this module. Time value of money refers to the fact that money received today carries more value than the same amount of money received at some other date in future. Money has a time value because it can earn more money over time. There are two techniques of time value of money: compounding and discounting. With the help of compounding technique, we can find out the future value of present money or future value of a present stream of money. On the other hand, we can make a rational calculation of some value to be received in future by using the present value formula. The present value formula is just a rearrangement of the future value formula. The concept of time value of money can be used in a variety of practical applications like sinking fund, capital recovery, and deferred payments.